All right, so here we have some short answer to help us prepare for the exam. Okay, here we go. Identify a laboratory process that can be used to separate a liquid mixture of methanol and water based on differences in their boiling point. So, methanol is an alcohol, and if they have different boiling points, you can't just say boiling. You can say distillation. Think about how alcohol is purified using distillation. So you boil it, and then part of it comes off, you cool and condense, and that's called the distillate. You can also say the verb distilling. All right, thermal energy is absorbed as chemical reactions occur through the baking of muffins. Batter for the muffins often contains baking soda, which is sodium bicarbonate, which decomposes as the muffins are baked at 200 degrees Celsius. The balanced equation below represents this reaction, which releases CO2 gas and causes the muffins to rise as they bake. The H2O liquid is released into the air of the oven as it becomes a vapor. State the direction of heat flow between the air in the oven and the muffin batter when the muffin batter is first placed in the preheated oven at 200 degrees. So the air is at 200 and the muffin is at room temperature. So we know that heat flows from hot to cold. So we're going to say from the air in the oven to the batter. So this is hot and this is cool. So from the air to the batter. All right. Identify the phase of chlorine at STP. So we've got different phases of different forms of chlorine and chlorine-containing compounds. The phase of chlorine at STP. So STP of chlorine. Well, chlorine at STP. You don't really need this, do you? Because you know that chlorine is part of the halogens. It is a gas. Yeah, I guess you didn't. You just had to know that, I guess. The gases on the periodic table are everybody in. Why am I drawing it? Everybody in. And of course, it's to the side. So the gases would be everybody in group 18, fluorine, chlorine, oxygen, nitrogen, hydrogen. Did I miss anybody? I don't think I did. Yeah. So that's just something we gotta know. Yeah, can't really derive it from there. At standard pressure, water has unusual properties that are due both to molecular structure and intermolecular forces. For example, although most liquids contract when they freeze, water expands, making ice less dense than liquid water. Water has a much higher boiling point than most other molecular compounds, having similar gram formula mass. By the way, at this point in the year, we have not talked about all those different things. Some of those concepts we have not touched on yet, but that's okay. Explain why H2O solid, which is ice, floats on liquid water when they're both at 0 degrees. Because ice is less dense. And it says so right there. Dense. Okay, so read. Explain in terms of types of matter why methane can be broken down by chemical means, but argon cannot. So methane. All right, methane. Well, first of all, if you go to table S, you realize that methane is not an element. Methane is a compound. Now, even if you don't know what the formula for methane is, you know that it's not on periodic table, it's not on table S. And argon it's an element. So your response must include both methane and argon. So you can say argon is an element, methane is a compound, which means it's two different elements bonded together. Okay? Yeah. So see how we talked about both of them. That's right. State one observation that indicates a chemical change has occurred. So chemical changes are changes in chemical structure bonding. So a dripless wax candle is masked and then lighted. As a candle burns, so burning of the wick. Okay. A small amount of liquid wax forms near the flame. Liquid is not, that's just melting. That's physical. But flame, after 10 minutes, the candle flame is extinguished and the candle is allowed to cool. The cooled candle is masked. So burning in flame, yeah, that's good. Read all that, of course. Draw at least 5 molecules of the product of this physical change at 120 degrees. Okay, so here's the chemical formula. The product is on this side. What is produced? H2O gas. So H2O gas, you've got hydrogen and oxygen. So if you didn't know that hydrogen bonds like Mickey Mouse, you will later. But so here's a water molecule, H2O. And here's another one. And sometimes they get flipped around. So why did I draw them in that fashion, taking up the whole box? It's because it says gas phase. Gas phase would take up the whole box. If we had a solid, it would be at the bottom like this, solid. But it said gas, so you're going to have them taking up the whole container. All right. Identify one physical property and one chemical property of CS2. So physical properties are things that we can observe, measure, or calculate. So CS2, carbon disulfide. Carbon disulfide is formed by direct reaction of carbon and sulfur at room temperature. Carbon disulfide is a colorless liquid with an offensive odor. So how about I say colorless? You could also say liquid. You could also say offensive odor, but you'd say one of those because it asks for one. Don't give me all of them. However, chemical properties are how it reacts. So you can say flammable, vapors. Don't tell me a chemical property is carbon is bonded to sulfur. No, that's not a property. You should talk about how it reacts. Although, as I'm reading the answer key right here, you can say carbon disulfide can break apart into carbon and 2 sulfurs. But I don't think at this point in the year we're ready for that. Base your answers here. Contrast sample A and B in terms of compounds and mixtures. Okay, so in compound A, that is one compound. It's homogeneous, which is uniform throughout. In box B, we have two compounds mixed, or you could say it is a mixture. It is heterogeneous. What else does it say here? Yeah, that's pretty much everything it says. Explain why sample C represents a mixture of fluorine and hydrogen chloride. So fluorine is diatomic, something like that. Hydrogen chloride would have a hydrogen and a chlorine. So explain why it could represent, because we have a diatomic and we have a compound. Explain in terms of the composition why sample A is a pure substance. Okay, so we've already mentioned this before. Homogeneous, uniform, same throughout. Okay, looks the same throughout. Explain how the average kinetic energy of sample B can be equal to the average kinetic energy of sample C. Average kinetic energy is temperature. So how could they be equal? If they're at the same temperature. Doesn't have anything to do with particle kind or particle arrangement. It's just as long as they're at the same temperature. What is the total number of, that's the other thing. I guess I put it in the wrong order. Well, anyways, I guess we could do this anyway. Q equals MC delta T. Mass is 25. Specific heat of water, 4.18. Find that on the front of the reference table. T final minus T initial. And you solve it. So, hold on. Come on. Just trying to X out of this. 25 times 4.18 times 36 minus 24, which would be 12. 1254 joules. Did not ask about sig figs. So there you go. If it did ask for sig figs, 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs would be 1250 joules. When salt, sodium chloride, is added to water in a 250 milliliter beaker, the temperature of the water is lower than the original temperature. Describe this observation in terms of heat flow. So heat flows from hot to cold. So the heat flowed from the water to the salt. And that's why, therefore, water temp decreased. Okay? All right. Thanks for watching. Reach out if you've got any questions.